Okay, let's start the experiment number 4. The aim of the experiment is estimation of serum creatinine. Let me know if my voice is audible or not. Amisa, Cap, and Wakim, tell me from uh, just unmute yourself and tell me if my voice is audible or not.
Sir, you are audible.
Okay, thank you. So let's start now. This experiment will
Okay, sir.
require some of the equipments and apparatus. So let's know what are the equipments and apparatus required. We require colorimeter, we require centrifuge, autopipettes, and test tubes. Okay, colorimeter helps you to take the optical density of our absorbance of the test and standard. Centrifuge is required to separate serum from the blood. All of you can mute yourself. Okay, autopipettes for so that we can measure the volume of serum and reagents, and test tube is for mixing the reagent and sample, right? Chemical required is creatinine kit and distilled water. So these are the requirements we need to arrange, and the sample we have to arrange. So sample can be taken as a plain sample. So from plain sample, we cannot we should not add any anticoagulant. So it should be the plain vial where we can collect serum, or we can collect a plasma from heparin blood. Okay. So this is the what the sample which is recommended for creatinine test. Now, general information about the creatinine. Creatinine is a waste product formed in muscle from the high energy storage compound called creatinine phosphate. So this creatine phosphate is a one of the high energy compound. They are stored in the muscle. Okay, and this creatinine, which is high energy compound, so they sometimes provides uh, energy to the cells whenever the cells require energy. So this creatine phosphate, uh, when it is not when it is metabolized, right? So this creatine phosphate after metabolic process, the end product or waste product of this creatine phosphate is creatinine here. So we consider here creatinine as a waste product of creatine phosphate, and this creatinine, when it is produced, so this is excreted from our kidney as a urine. So we should know that there is a difference between creatine and creatinine. Okay, creatinine is a waste product of creatine. Creatine is a protein, right? Small peptides. And here we will know that the creatinine is removed from plasma. Like once the creatinine comes in the plasma after the metabolic activity of creatine phosphate. So from the plasma, it goes to kidney, and there is a glomerular filtration. That is a filtration process in the kidney, and which removes the creatinine. Okay, it used to excrete, and which can be you can see in the urine also, right? And this creatinine is not reabsorbed by the tubules. Okay, there is no reabsorption process. So this is the what we know that the creatinine is one of the marker for kidney function test. If creatinine is being excreted from the urine, then it means the kidney is normal. If the kidney is not being excreted by the kidney, it means the kidney is abnormal. Okay, so creatinine test is one of the one of the tests which is an indicator for renal function, kidney function. We can use, if you want to assess your kidney that it is functioning normally or it is functioning abnormally. In such condition, we can understand that creatinine test should be done, right? Serum creatinine levels do not start to rise until renal function has decreased by at least 50%. So what we have to understand that a renal function, right? When the renal function is decreased by 50%, so only after that the creatinine level start to rise, right? So if the creatinine level increases, in the blood, it means you have to interpret it that the renal function has decreased its function by 50%. Let's know the principle of the test. There are two principles we are going to know. One principle here, this is the Gibbs method, where picric acid is a reagent. So in alkaline medium, it reacts with creatinine and it produces orange color, complex. This is the reaction you can see here. Yeah. So creatinine plus alkaline picric, creatinine in the sample, and this is the reagent. So alkaline picric acid, now it gives orange color complex. This color you can measure the intensity of the color using the colorimeter, and then you can compare with the standard and you can get the result. So intensity of the color formed is directly proportional to the amount of creatinine present in the sample. Okay. Next principle we are going to know, it's based on enzymatic method. It uses three enzymes as a reagent. One is a creatinase, second is a sarcosine oxidase, and the third one is a catalase. So these three enzymes can be used as a reagent here. And creatine, which is generated from creatinine by creatinase, okay, is hydrolyzed sequentially by creatinase and sarcosine oxidase to produce hydrogen peroxide. So the sample that contain creatinine, so when you add the sample in the reagent, so the reagent contains these three enzymes. The first enzyme, creatinase, okay, converts creatinine into the creatine. Then after the action of sarcosine oxidase, it converts into the hydrogen peroxide, right? So the hydrogen peroxide which is formed is coupled with the this N-ethyl, N-sulfopropyl, M-toluidine. So this is ESPMT. This is the chromosome. So this chromosome is allowed to react with the the product of the reaction that we get from the hydrogen peroxide and peroxidase. Peroxidase will break down the hydrogen peroxide, and we get nascent oxygen, and which will oxidize this ESPMT chromosome, and we'll get a color. Now the absorbance of the product, absorbance which is that we can measure at 546 nanometer. Okay, the color is directly proportional to the creatinine concentration in the sample. So this is the what we need to select the wavelength in the colorimeter, and we can take the absorbance of the test. Now let's know the procedure of the method. This is the enzymatic method we are going to do as a procedure. Now take 3 cleaned and dried test tubes. So we can take 3 test tubes, but here we have shown in the table only 2 test tubes. So let's we can label it as a T for test, S for standard, B for blank. Okay, and the pipette the following ingredients in the respective test tubes. So this is the two test tube has shown. One is for test, another is a standard. So working reagent we can you can keep 1 ml in the test and another in the standard. Serum we can add 0.1 ml in test, and standard we can add 0.1 ml in the standard. Now what we can do, we can set the spectrophotometer to 0 absorbance with distilled water. So this is a third tube, that is a what with a blank, where we can add distilled water, which can be used as a blank, and we can calibrate the spectrophotometer by selecting the wavelength, this one 500 to 520, and we have to calibrate 0 first. Then we can take the initial reading after 20 seconds, that is A1 after mixing. So this is the first absorbance we can get after 20 seconds. Then we can take final reading at 80 seconds. Now calculation is that we can take the change in the absorbance. So we have recorded 2 absorbance, one at the 80 second, another at the 20 second. So difference of this is the delta absorbance, and we can calculate the creatinine by this formula: change in absorbance of test, and then change in the absorbance of the standard multiplied by standard concentration. This is the formula, and we can get the result. Now the normal range is serum and urine. We can do the test, and then serum, the male has 0.7 to 1.3 mg per dl, and urine is 14 to 26 mg per kg per day. This is the value for normal range in male, and for female we have to consider that this is the value in the serum. Okay, in the female 0.6 to 1.1 mg per dl, and the urine of the female contain 11 to 20 mg per kg per day. So newborn and then infant, child, adolescent, they have different level of normal range. And here we can convert the mg per dl into the micromole per liter. So mg per dl multiplied by 88.4 gives micromole per liter. So this is the what we have studied about the procedure, principle, and normal range, and some general information about creatinine test, which can be done with the serum as well as urine. Now we have come to the end of the slide. Related to this, if you have any confusion, you may can ask me. We can discuss what if there